First things first, why the title? Well, that was actually advice given to me from Professor Hoke. He said that if you are going to write a paper and by its very nature, it's not possible for you to include every aspect of a given topic, to avoid people from being able to have a go at you and say that you haven't included this or you haven't included that. If you use on some at the start of a paper, then that deals with it. So I followed his advice, and it's called On Some Positive and Negative Aspects of Shewhart Charts. People who assisted me in writing it, Professor Douglas C. Montgomery at Arizona State University, he let me call him at home to talk about control charts. That was very helpful. Dr. Emmanuel Yashin, he allowed me to interview him. He was working at where was he? Dr. Yashin was at IBM Mathematical Research Department in New York, and some other folks as well. So this is the thesis itself. I'm going to deal with section 1, dealing with the positive aspects of Shewhart charts, and I'm going to share it right now. Okay, positive aspects of Shewhart charts. I'll narrate it and then give some thoughts after I've finished. So, a plot of the data itself. So the data which are plotted onto a Shewhart chart are statistics from some process, and as they're taken over time are longitudinal in nature, in other words, a time series. A crucial first step when one is dealing with longitudinal data is to plot it in order to gain some insight into the behavior of the process itself. In so doing, one may notice extremely insightful aspects of the process, for example, a non-constant mean and/or seasonal components. As is mentioned by Box, Coleman, and Baxley in 1997, an advantage of the Shewhart chart is that since it is a plot of the data itself, it's like a multidirectional radar that might find quite unexpected signals. For example, every fifth value is high, and so reveal quite unexpected means of improvement. In fact, it has been noted that the very act of measuring quality characteristics of some manufactured product may lead to improvements. As Ryan, 1989, commented, the mere maintenance of control charts often leads to a reduction in product variability simply because operators realize that management is placing considerable emphasis on product quality, and this causes them to exercise greater care. Patterns which may be exhibited via a sequence plot of the data itself may suggest further analysis, potentially towards the elimination of special causes of variation. It should also be noted that rival control charts, in particular the cumulative sum, or QSUM, and exponentially weighted moving average charts, EWMA charts, do not plot the computed statistics as such clear representations of the data. Hence, it would not be so easy to spot specific patterns as easily as by making use of the Shewhart chart scheme. Of course, these other types of control charts have their own methodology for discerning patterns, though they are not as simple as that of the Shewhart chart. As Wheeler, 1991, noted in dealing with the QSUM technique, because of its use of transformed data, the QSUM approach does not generally produce the same sort of profound insights into the production processes that are routinely associated with Shewhart control charts. When such insights are obtained, there is a higher probability that the actions taken will be more in line with what should be done, as opposed to tampering, which is discussed in the following section. As is discussed by Feldner, 1994, simplicity has major practical benefits. When operators have a good understanding of the SPC technique, they are much more likely to respond effectively to the signals it generates. All right, what am I talking about there? Here's my opinion of Shewhart control charts. And I agree with what I wrote, which is a good job. The very act of plotting data over time, I think I appreciated it at the time, but now 25 years later, I really do appreciate it a great deal. By putting these points on a chart, and especially having senior management look at these results over time, you can see if things are happening. Now, I always worry about people talking about trending over time and things like that, possibly seeing information in control charts or just time series plots that they want to see. That's why we have these extra tests that are going to be talked about later on in the thesis, the Nelson run rules, for example. But the actual act of plotting the results is very worthwhile. I was alluding, but I didn't state it there. I don't quite know why not, but to the Hawthorne effect. So the Hawthorne effect is actually a flawed design experiment. It was flawed because one area of the factory got more lighting than the other, so it was a confounded effect. But the moral of the story, the big deal with the Hawthorne effect is the very act of being involved, getting involved, and measuring something uh, has a tendency to improve it. Now, I can remember when I was at primary school, you're going to have your teacher lurking over your shoulder, making sure that you're doing what you're supposed to be doing. So, but I was just a little kid there, but you grow up, you're still doing this stuff. But if you're shining a light on these business activities, then it's going to be the case that more often than not, you would hope that the results that you're going to be seeing are more in alignment with best practices. The process will be in a state of control if we want to use ICH kind of guidance. I'm not entirely sure why I was having a go at QSUM charts and EWMA charts. I was kind of having a go at the fact that the fact that those charts are using statistics. Okay, so let's say an individual's chart, a Shewhart chart for individual results. Yeah, that's just an individual result itself. An X bar chart, okay, we're taking the mean from a rational subgroup and plotting that mean. So it's not the individual values. Most of the time, I find that in the biopharmaceutical industry, we're using individuals charts or X charts, as they're sometimes called. And that's good. You're seeing the individual values themselves. The rational subgrouping that makes sense is n equals 1. Fine, I have no issue with that. QSUM charts and EWMA charts, exponentially weighted moving average charts, yeah, they are not using the actual values themselves. So there have been several instances where I have advised people to kind of shy away from using, especially QSUM charts, to using an individual's chart, but also layering in an appropriate Nelson run rule that would give you the kind of false alarm rate or average run length that you would get that would be commensurate to using a QSUM chart or an EWMA chart. Why do I do that? Because I found that in practice, using an individual's chart with the actual results themselves are going to give you more bang for the buck than using an alternative chart and trying to persuade people, oh, look at what this V mask is doing or something like that with a QSUM chart. Now, I've found that this argument of using the individual's results themselves does have a great deal of value to it. So that's an okay point. All right, that's section 1. Section 2 is next.